This is the pre-calculus midterm review. We need to find the value of f of negative 6. Now we first need to look over here to determine which piece of the piecewise function we would substitute this in for. Since negative 6 is less than negative 3, we would substitute it into the first piece of the piecewise function. So we're going to do negative 4 times x plus 3. We know our x value is negative 6. So negative 4 times negative 6 gives us 24. And 24 plus 3 tells us the answer is 27. This time, our x value is going to be negative 1. Again, we're going to determine which piece of our piecewise function we would substitute into. And negative 1 is between negative 3 and positive 12. So we're going to use the middle piece of our piecewise function. So we have x squared plus x plus 1. Our x value, we know, is negative 1. So negative 1 squared gives us a positive 1, minus 1 plus 1 will just simplify to be 1. Determine between which consecutive integers the real zeros of each function are located in the given interval. So we need to look at this function from the x value of negative 2 to the x value of 4 to determine where the zeros would lie. Now we know we're going to have a 0 if our y values go from a positive to a negative or from a negative to a positive. So we're looking at the integers from negative 2 all the way up to 4. So from negative 2, negative 1, 0, 1, 2, 3, and 4. Now if you take each of these and plug in your x value into the equation, you will get the following y values. So we are looking for where the zeros would lie. As you can tell, there are no zeros that lie directly on an x value that is an integer, but we can see where they will fall between. We go from a negative y value to a positive y value when x is between negative 1 and 0. We go from a positive y value to a negative y value when between x is 0 and 1. And we go from a negative y to a positive y, which again means you had to have crossed 0 at some point, between the x values of 2 and 3. Describe the transformation of how f of x and g of x are related. So because we have the 3 multiplied out front by the entire function, this means it's going to be vertical. Since the value is greater than 1, it is going to be expanded vertically by a factor of 3. Because this 8 is attached just to the x, when you pull it out, you will have to change the sign. Because it's on the x, it's either going to translate left or right. But when we pull it out, we change the sign, so this becomes a negative 8. So this means we are going to translate to the left 8 units. We need to find the inverse and state any restricted domains of the function. So first, you would need to graph the original function to see what the range is of the original function. And your graph would originally look something like this. It has a domain of all real numbers, and it has a range of y has to be greater than 0. So whatever the range is of your original function will be the restricted domain of your inverse function. Now remember, to find the inverse, you're going to start by just taking, remember f of x, just another way to write y. But to find the inverse, you just take your x and y and you switch the places. So we're going to say x is equal to 6 over the square root of 8 minus y. Now our goal is just to get the y by itself again. So we can start by multiplying both sides by the 8 minus y to get that y out of the denominator. Now we have x times that radical. To get the x the other side, we would divide on both sides. So this is going to give us radical 8 minus y is equal to 6 over x. To get rid of that square root, we would square both sides. When you square both sides, remember that you have to square the top and the bottom separately. Now to get the y by itself, we can subtract 8 from both sides. This is going to give us negative y is equal to negative 8 plus 36 over x squared. But we still have a negative attached to that y, so we can divide each piece by a negative 1. And we're going to get that y is equal to 8 minus 36 over x squared, or our inverse function is 8 minus 36 over x squared, which has a restricted domain of x has to be greater than 0. Remember, this domain is the same as whatever your range was. Your range is y, but because this is the inverse, this will now be our x. Use the graph of the function to state the domain and the range. Now, to find our domain, we want to find where this asymptote is located. We know that there's going to be an asymptote located somewhere through here. It is a vertical asymptote. You will always know where those are because the denominator cannot equal 0. So to find the exact value for our domain, we can set 3x minus 5 cannot equal 0 because our denominator cannot equal 0. So if we add 5 to both sides, we're going to get 3x is cannot equal 5. We can divide both sides by 3, and we'll see that x cannot equal 5/3. So you can write your domain as x cannot equal 5/3, or you can write this as it goes from negative infinity to 5/3, and it goes from 5/3 to positive infinity. Either form I will take as your answer. Now if we look at our range, there is a horizontal asymptote on this one as well. Because the degree of the numerator and the denominator are exactly the same, we do know that our horizontal asymptote is going to be at an over bm, which remember is the leading coefficient on the top over the leading coefficient on the bottom. So negative 6 over 3 or negative 2. So we do know for our range that y cannot equal negative 2, or you can write this as a negative infinity to negative 2, or negative 2 to infinity. Again, I will take that answer in either form. We need to state the end behaviors of this. Again, this is the same graph, so we do know that it is approaching but never touches y equals negative 2. So on the left side of our graph, the graph is getting closer and closer to y equals negative 2, but never actually touching it. And on the right side of our graph, the limit on the right side, again, it's getting closer and closer to that y equals negative 2, but never actually touching it. We need to estimate the intervals on which the graph is increasing, decreasing, or constant. So if you look, you can see that the graph is going down here. It goes up here, and then it's going to go down again here. So we just need to name those intervals. When you name these, you are looking at the x values, not the y values. So we're starting here at an open circle, so this will be a curly bracket, and that's at the x value of -4, and it's going to continue until we get to the x value of -2. We don't have a circle there, so we don't know if it's a closed circle or an open circle. We don't know if it's going to touch it exactly, so we can go ahead and leave that as a curly bracket. And we know in that interval it is decreasing. Now, from where x is -2 until we get to where x is a +2, the graph is then increasing. And then from that +2 as our x value until we get to the x value of 4, this one is a closed circle, so this one does need to be a square bracket. The graph is decreasing again. We need to solve this equation. To do this, all you have to do is get the x by itself, remembering to reverse the order of operations. So the first thing we need to do is get rid of this 14, so we can subtract both sides by 14. This is going to leave us with the cube root of x minus 5 squared is equal to 36. Now to get rid of that cube root, we can cube each side. So this is going to leave us with x minus 5 squared is equal to 46,656. Now to get rid of the square, we can take the square root of both sides. But remember, when you take an even root, you need to have plus or minus with it. So this is going to give us x minus 5 is equal to plus or minus 216. So we have x minus 5 is equal to a negative 216, and x minus 5 is equal to a positive 216. We're going to solve each of these just by adding 5 to both sides. Now, because we did have to do a plus or minus, you should check that both of the answers work. Make sure neither of them are extraneous solutions. So you should plug them back into the original. And if you do, you will see that both of these answers do work correctly for this problem. We need to state the number of possible zeros and turning points for the function. So remember, these do need to be in descending order. So the largest exponent should come first, and then they should get smaller in the exponents as they go down. This one is in the correct order. If it's not in the correct order, make sure you rearrange first. But whatever that largest exponent is your n value. So our number of possible zeros is just whatever your n value is, which in this case would be 5. The number of possible turning points would be n minus 1, or 5 minus 1, which for this problem would be 4. We need to find all of the real zeros by factoring. Now, if you notice, you will see that each of them have x's attached, so we can factor some x's out before we start. We can actually factor out an x to the third power, which will leave us with x squared minus 7x minus 8. From here, we can factor again. What multiplies to get x squared is x and x. What multiplies to get a negative 8 that adds to get a negative 7 would be a positive 1 and a negative 8. Now, when you pull these out to find the answers, we are going to have, we know that this whole thing is equal to 0. So we know that x to the third is equal to 0. We know x plus 1 is equal to 0, and we know that x minus 8 is equal to 0. If we solve each of these, the first one will just be x is equal to 0, but because it is cubed, we know it's happening 3 times, so we know it has a multiplicity of 3. The next one, if we solve for x, we're going to get x is equal to negative 1, and the last one we will get is x is equal to positive 8. Use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of the function. So we need to check x plus 2 and x minus 4. To do this, remember each of these are equal to 0, so you're first going to solve for x. So we're going to check when x is negative 2 and when x is equal to 4. So if we check negative 2 first, we're just going to pull down the coefficient. Remember, if there's any exponents that are skipped, you do need to put in a 0 as a placeholder. We do not skip any coefficient or any exponents on this one, so we do not have to put any placeholders in. Remember, you bring the first number straight down. Negative 2 times 3 gives us negative 6. If we add down, we're going to get negative 18. Negative 2 times negative 18 is going to give us a positive 36. Add down, we're going to get 15. Negative 2 times 15 is going to give us a negative 30. If we add down, that's going to give us a 36. Negative 2 times 36 is a negative 72. If we add down, we get 0. Since we did get 0, that means it is a factor. So we do know that x plus 2 is a factor of this function. Now we need to check to see if 4 is a 0 of this function. Because the first one already worked, we can just bring those values straight down to try to factor it farther. So 4 times 3 gives us 12. If we add down, we'll get negative 6. 4 times negative 6 gives us a negative 24. Add down, it's going to give us a negative 9. So it'll give us a negative 36. Add down, that gives us 0. So that means both of these are factors of the function. So we can write this as x plus 2, x minus 4, and then what we're left with, we were to the 4th power. So this was x to the 4th. After dividing once, that would leave us with x cubed. So when we started this one was x cubed. Divide by another x, that'll leave us with x squared. So we have 3x squared minus 6x minus 9. If you notice, there is a factor of 3 involved in each of those, so we can factor out a 3, and that'll leave us with x squared minus 2x minus 3. And we can factor that once again. Multiplies to get x squared is x and x. Multiplies to get negative 3, that adds to get negative 2. That'll be negative 3 and a positive 1. So this will be the completely factored form of our function. Determine any vertical, horizontal asymptotes, holes, and intercepts of the function. To do this, the first thing we need to do is we need to factor the numerator and factor the denominator to see if we have anything in common. We're looking to see what multiplies to get negative 15 that adds to get a positive 2. So that would be a positive 5 and negative 3. What multiplies to get a negative 12 that adds to get a positive 1 would be a positive 4 and a negative 3. As you can see, we have an x minus 3 on top and bottom. So we know there will be a hole in our graph where x is equal to 3. Then we can go ahead and cross those out so we know that's already taken care of. Your vertical asymptote is any x of the denominator that is not a hole. So in the denominator, we would also have an x. When you pull that out, it would be x equals negative 4. To find your horizontal asymptotes, we need to look at the degree of the numerator and the denominator. Since the degree of the numerator and the denominator are the same in this case, to find your horizontal asymptote, you are going to do an over bm, which means the leading coefficient of the top over the leading coefficient of the bottom. So our horizontal asymptote will just be y is equal to 1. Your x-intercept are any zeros of the numerator that are not already holes. So that would be x equals negative 5. And to find your y-intercept, you're just going to plug 0 into the original function. So we're going to do 0 squared plus 2 times 0 minus 15 all over 0 squared plus 0 minus 12. or negative 15 over negative 12, which would simplify to give us a y-intercept of 5 over 4, or 1.25. We need to solve this equation. We're going to solve for x. First, we can start by factoring this denominator, and this is going to give us multiplies to get 8, adds to get negative 6, will be negative 2 and negative 4. So this can replace that part. Now, we need to see what we can multiply everything by to get rid of all of the denominators. If we multiplied everything by x minus 2 and x minus 4, this would cancel all of the denominators. So right now we have 4 over x minus 2, x minus 4, and we can multiply that by x minus 2, x minus 4. We have 3x over x minus 2, and we can multiply that by x minus 2, x minus 4. We have 2 over x minus 4, and we can multiply that by x minus 2, x minus 4. Now we can see what we can cancel. I have an x minus 2 here and an x minus 4. Both of those things are going to cancel. Here my x minus 2's will cancel, and here the x minus 4's will cancel. So this will leave us with 4 is equal to 3x times x minus 4 plus 2 times x minus 2. If we distribute, we will get 4 is equal to 3x squared minus 4x plus 2x minus 4. We can take everything to one side, and then we can factor. So if we subtract that 4 from both sides, we're going to be left with 0 is equal to 3x squared minus 2x minus 8. I did not distribute correctly. This should be a negative 12. So this will give us negative 10x. Now if we go to factor this, what multiplies to get 3x squared is 3x and x. We need to find something that multiplies to get negative 8, that when we check it with our FOIL, the O and the I, multiplying the outside and the inside, will give us a negative 10. Now multiply to get negative 8, we have 4 and 2. So if we multiply these outside pieces, that'll give us a negative 12. Multiply the inside pieces, that'll give us a positive 2. Negative 12 plus 2 does give us that negative 10. So we do know that 3x plus 2 is equal to 0, and x minus 4 is equal to 0. If we solve for x, we're going to get that x equals negative 2/3, or x is equal to 4. But if we look back at the original problem, in one of our denominators, we have x minus 4 as a denominator. If we were to plug in a 4, 4 minus 4 gives us a 0. You cannot have a 0 as a denominator, so the only answer that works is a negative 2/3. We need to expand this expression. Remember, if it's multiplication, to expand it, it becomes addition. If it's division, you expand it, it becomes subtraction. And if you have an exponent, when you expand, you bring it out front. So let's deal with our multiplication first. Well, let's split up our division, and then we'll deal with multiplication. So division becomes subtraction. So I have log base 3 of 4df to the 5th minus log base 3 of the 8th root of 1 minus 3d. So we took that division, we separated it into two different parts by making a subtraction. Now each of these multiplications we can separate because multiplication becomes addition when you expand. So log base 3 of 4 plus log base 3 of d plus log base 3 of f to the 5th. And we still have the log base 3 of this part. Now another way to write the 8th root is we can raise this to the 1/8 power. Now anything that is a power, we can bring to the front of that log when we expand. So our final expansion will be log base 3 of 4 plus log base 3d plus 5 log base 3 of f minus 1/8 log base 3 of 1 minus 3d. We do need to make sure we keep those parentheses because it shows it's all of that stuff together inside of that log. We need to solve this equation. The fastest way to do these is to see if you can make the bases the same. Now 4 is 2 times 2, and 8 is 4 times 2, which 4 is 2 times 2. So we can write 4 as 2 squared raised to the x plus 2, and 8 is 2 to the third raised to the x plus 6. When you raise a power to a power, you multiply. So this is 2 raised to the 2x plus 4 is equal to 2 raised to the 3x plus 18. Now because the two bases are the same, we can now set the exponents equal to each other. So we can say 2x plus 4 is equal to 3x plus 18. Now we just need to solve for x. We can subtract 2x from both sides. That'll leave us with 4 is equal to x plus 18. To get the x by itself, we need to take the 18 to the other side. So to do that, we can subtract, and we'll get negative 14 is equal to x. We need to solve this logarithmic equation. Again, you want to get that x part by itself. So the first thing we can do is subtract that 15 from both sides. This will leave us with 3 ln of 5x is equal to 12. Right now we have 3 times that quantity, so we can divide both sides by 3, and we'll have the ln of 5x is equal to 4. Now remember, ln is actually log base e. So if you want to get rid of that e, you can make the base of both sides e, and everything else will now be raised as an exponent. And e raised to the ln, the e and the ln actually cancel. So you're going to be left with 5x is equal to e to the 4th. We can divide both sides by 5 to get the x by itself, and we're going to get x is equal to 10.9. We need to solve this equation and round to the nearest hundredth. We have e. To be able to cancel that e, we can take the ln of both sides. So we can do the ln of e raised to the 2x minus 5 is equal to the ln of 42. Now the ln and the e will cancel, and we'll just be left on that left side with 2x minus 5 is equal to that ln. If we write it as a decimal, the ln of 42 is 3.737669618. To get the x by itself, we are going to add 5 to both sides. We can then, to get the x by itself, divide both sides by 2. And it does tell us to round to the nearest hundredth. So when we divide by 2, we just rounded 2 decimal places. We will get 4 is equal to 3.7. We need to find the area of this sector. To find the area, we do 1/2 r squared times theta, where theta must be in radians. Since our angle is given to us in degrees, we first have to convert it to radians. So 146 degrees, to turn that to radians, remember you multiply by pi over 180. If we simplify this, I know that 2 will go into 146 73 times, 2 goes into 180 90 times, so I can write this as 73 pi over 90. Right now we know that the diameter is 21.4, so that means the radius would be 10.7. So if we plug this into our area formula, our radius is 10.7 and our theta is 73 pi over 90. So this will give us an area of 145.87 kilometers squared. We need to use Heron's formula to find the area of the triangle. Now, the area of the triangle formula for Heron's is S times S minus A times S minus B times S minus C, where S is 1/2 of A plus B plus C. So if we find the value of S first, we're going to see that S is going to be equal to 40.5. So if we need to find the area, we're going to do 40.5 times 40.5 minus the length of the first side times 40.5 minus the length of the second side times 40.5 minus the length of the third side. And this will give you an area of 167.6 millimeters squared. Both Derek and Sam are 6 feet tall. Derek looks at a 10-foot basketball hoop at an angle of elevation of 31 degrees. And Sam looks at the goal at an angle of 48 degrees. If Sam is directly in front of Derek, how far apart are the two boys standing? So we know that the basketball hoop is 10 feet tall, but we know that the boys themselves are 6 feet. So that only leaves us with 4 feet for the height of this triangle. Now we can find the distance from Sam to the basket as our x, and the distance from Derek to the basket as our y. And once we know those two values, to find the distance between them, we can just subtract our x and y values. Now because this is my angle, this side is between the angle and the 90, so it's my opposite side. This side is across from the angle, across from the angle is the opposite. Between the angle and the 90 is our adjacent side. So this means we are going to use our tangent function. So for Sam, I'm going to say the tangent of 48 degrees is equal to the opposite side over the adjacent side. And for Derek, the tangent of 31 degrees is equal to the opposite side over the adjacent side. Now to get the variable out of the denominator, we are going to multiply for Sam both sides by x and for Derek both sides by y. So for Sam, we're going to have x times the tangent of 48 is equal to 4. And for Derek, we're going to have y times the tangent of 31 is equal to 4. Now to get the variable by itself, we are going to divide both sides by the tangent. So for Sam, we're going to have x is equal to 4 over the tangent of 48. For Derek, we're going to have y is equal to 4 over the tangent of 31. And if you make sure your calculator is in degrees, you are going to get x is equal to 3.602 as how far Sam is away from the basket, and y is 6.657 is how far away Derek is from the basket. So to find the distance between the two boys, we will just take how far each boy is from the basket and subtract it from each other, and you'll be left with 3.1 feet between the two boys. we need to find the exact value of the expression. So we're going to start with the stuff on the inside. We need to find the inverse tangent of radical 3 over 3. Now remember, when you're looking at tangent, you can only look at the right half of our unit circle. And we are looking for when tangent is y over x. We want a y over x that when we simplify it, we're going to end up with a radical 3 over 3. So if we're only looking at the right side of our unit circle, and we need it to be positive, the only place we have both positive coordinates and we have a radical 3 involved is going to be at pi over 6 and pi over 3. Now, if we look at pi over 6, if we do y over x, we would have 1/2 over radical 3 over 2. When you have a fraction over a fraction, remember you flip the second one and you multiply. Those 2's are going to cancel, so this is going to give us 1 over radical 3. You cannot leave the radical in the denominator, so you would multiply the top and the bottom by a radical 3, and this would give us a radical 3 over 3, which is what we had. So we will have a tangent of radical 3 over 3 when our radian measure is pi over 6. So we can replace this piece with pi over 6. Now we need to find the sine of pi over 6. Remember, sine is the y coordinate. So if we come here and we look at pi over 6, we look at the y coordinate at that angle, we will get 1/2. So the sine of pi over 6 is a positive 1/2. Solve the triangle, find side lengths to the nearest tenth and angle measures to the nearest degree. So angle A is 42 degrees. We do not currently know side A. Side B is 12 and side C is 19. Because we don't currently have any sides across from any angles, we will have to start with the law of cosines. So we're going to do 12 squared plus 19 squared minus 2 times 12 times 19 times the cosine of 42 degrees. Now because we are trying to get the a by itself, right now it's a squared, so we can take the square root of both sides. You can put all of that in your calculator at once, and you will get the length of side A is 12.9. Now once you have one side across from an angle, we can switch and use law of sines. So I know the sine of 42 degrees goes with 12.9, as the sine of angle B goes with 12. If we cross multiply and divide, we will get the sine of angle B will be 0.6224. When you're looking for an angle, you want to move just the sign. Remember, you use the inverse. And we will get that the measure of angle B is 38 degrees. Now, once you know two angles in a triangle, to find the measure of the third angle, we know inside a triangle there's 180 degrees. I've already used 42 degrees for angle A and 38 degrees for angle B, so we know the measure of angle C, we will have 100 degrees left.